We all know about Snowflake's unique time travel feature, which allows us to undrop a mistakenly dropped table in production environment, or go back to the previous state of the table, or create a snapshot via cloning. But they all come with extra cost, and sometimes it is very expensive if you don't consider time travel parameter at account level or database level or table level correctly and understand your data protection risk for the project. Snowflake's time travel feature enables a data team to work effectively only if you have understood it correctly and designed your tables as per your project requirement. So, we are going to learn everything about the time travel duration for standard to higher Snowflake editions, difference between time travel period and the fail-safe period, how to use extended SQL to leverage time travel features, how to clone and create snapshot tables, role of time travel for transient and temporary tables, time travel parameter at account level to DB to schema levels, drop and undrop database schema and table, and many more fact about time travel feature. Welcome back to my channel Data Engineering Simplified and to this real Jumpstart course for Snowflake data professionals. The last 13 episodes in this series already covered from history to architecture, bulk data loading to continuous data loading, unique features to multi-cluster warehouses, micropartitions with examples, and many more important concepts. This episode, the episode 14th, will primarily focuses on time travel and continuous data protection concept in Snowflake and understand its power and limitations besides its cost component. We will practice everything using Snowflake free trial edition and have hands-on exercise to cover all the concepts listed in this slide. Many of you like this tree map approach as it keeps us focused without wasting any time. So let's review it quickly before we elaborate the time travel concept. The first part will focus how time travel works, time travel parameter, Snowflake editions and time travel feature applicability, time travel versus fail-safe concept. Next, we will jump into and understand the SQL construct related to the time travel. We'll see how to enable a time travel feature for a table as well as how to clone using a time travel. We'll look into the add before, offset and statement syntax. We'll see how you can use a join using a time travel feature. We'll see drop and undrop concept. Next, we'll see time travel and the cloning feature, followed by the cost associated with the time travel concept. And we'll try to understand the table which are capturing the time travel related storage metrics. So let's start. Before we proceed further, I have a small announcement to make. If you really want to master Snowflake Cloud Data Warehouse, I would recommend you to look into my channel's playlist. The playlist section includes SnowPro and Advanced Certification Guide, mock question series, important SQL functions, Snowflake connector series, Snowflake features and limitations, and many more real-life hands-on videos. By watching my free video series, many data engineers, leads, and architects, and even managers are getting certified in SnowPro Core and Advanced Certification. And the success rate is very high. I'm not lying. Just look into the comment. You don't need to buy any expensive courses. Just subscribe to my channel and I guarantee that you would easily learn this technology and get certified in just few weeks. So one small favor, if you are learning from my channel and my content, please hit the like button. When we talk about time travel, we would like to see how data looked like at some point in time in the past or in the history. The purpose or use case could be anything. For example, analyzing our ETL or ELT process and how it changed the data from state 1 to state 2, or restoring data that accidentally modified or updated or deleted, taking a backup from the past, and many more interesting use cases. So let's understand it in detail. We have a customer table and data is loaded via copy command, and we can say it is day 1 and a time t1 and a version v1 data with a query ID ending with 000. Next day, an ETL job perform an update operation that updated one or more rows and changed the state of the data, and we can represent it with a day 2, time t2 and version v2 with a query ID ending with 111. A few more DML operations executed, and that may include insert, update, and or delete SQL statement. And that's how we reaches to the day 9 and the time T9 with version V9 having a query ID ending with 999. Now in traditional database system, it is hard to see how data looked like at version V2 or version V1 and any version or state of the data between V1 to V8 when your current state of the data is V9. However, in Snowflake, we can look back up to 90 days of historical data, and that is we call a time travel in Snowflake. The default time travel duration is 1 day for standard edition and it can be set as a 0-2. If you try to change this value higher than 1 for standard edition, you will get an SQL error. Time travel duration is also known as retention period, and this can be changed at account level using a parameter function. This parameter is known as data retention time in days. For enterprise edition and above, you can set up this value from 0 days to 90 days. Now let's elaborate this example and see what all I can do using extended SQL to leverage the time travel feature. If I just write a query, select star from customer table, it picks the state of the table from V9 and display the result. If I want to see how data looked like at V2, then I can use extended SQL, which is not ANSI standard SQL, and we can use time travel SQL keywords like at or before and fetch the result. So here I am writing SQL statement, select star from a customer table at statement ID equals to query ID ending with 111, and this brings the state of the data at version V2. So at is the keyword which allows me to fetch the historical data, and you have to pass statement ID so Snowflake knows what to pull from the history. I can also use before keyword and see how data looked like before version V2, and the syntax goes like this. Select star from a customer before with statement ID ending with 111, and it pulls V1 state of the table data. So this is how the overall extended SQL for time travel works. This is not the standard ANSI SQL keywords. You can use keyword offset in place of at keyword if you don't remember exact query ID. The offset allows you to go back to X second back in history from your current timestamp. The syntax goes like this. Select star from a customer at offset and values in second. In this case, I want to see how data looked like 300 seconds back, and here you can also use expressions. Alternatively, you can also specify the timestamp and fetch the dataset. So this is how all the different extended SQL works. So we have 3 ways to fetch the data from the history using a time travel feature. Using statement or a query ID. Another option is that using timestamp keyword. And third option is using offset keyword, and this is how they look like. You can use any one of them based on your use case or your business requirement. Don't worry if they are not very clear to you. We'll see them using the free trial edition shortly. Snowflake also talks about a concept called failsafe, and many Snowflake developer thinks that failsafe is an extension of time travel. No, it is not. Let's understand the purpose of failsafe. The time travel can be defined for a table, and it can be 0 to 1 day for standard Snowflake edition and for 0 to 90 days for enterprise edition and above. Let's take the same example where we loaded the data and we can define the state of the data as a V1 on a day 1. On the day 7, we can say the state of the data is V7, and on the 97th day, we can say the state of the data is 97. So this is how it looks like. Each of this version are having a query ID, so we can always access this data through the extended SQL. For this table, assume that we have given the time travel value as a 90 days. A Snowflake user can access the data for this period, and once this period is over, the data goes to failsafe storage layer, which is fixed of 7 days for a permanent table and 0 days for transient and temporary table. If you have to extract data from the failsafe storage layer, you have to contact Snowflake support team, and there is no way that you can use extended SQL or any other mechanism to extract it. Failsafe's primary intent is very different from the time travel feature. Failsafe ensures historical data is protected in the event of system failure or other catastrophic event, that is a hardware failure or a security breach. Failsafe is not provided as a means of accessing historical data after the time travel retention period has ended. It is for use only by Snowflake to recover data that may have been lost or damaged due to extreme operational failure. We know Snowflake allows us to create transient and temporary tables, and we will understand how does it work with time travel feature. When we talk about temporary or transient tables, the time travel behavior is slightly different compared to permanent tables, and we'll try to understand with an example. So let's say we have a customer table and the table is defined as a transient or a temporary table. We have covered this concept in a chapter 7 and please refer the link above. So we start with the table version v0 where data is loaded via copy command. Then an ETL performs some update operation on a day 1 at a time t1. At this point, we can access data for last 24 hours or we can say for last 1 day. As we move to the next day, the next ETL operation happens, we would not be able to access v0 version data as it is outside of the 24 hours window or a 1 day window for temporary or a transient table. Then further ETL operation happens, and if we reach to the 90th day, we would not be able to access any data from v0 or a v1 or a v2, and we would be accessing only the current date time minus 24 hours of historical data and not beyond that window for temporary and the transient table. And that is one of the big difference with transient or a temporary table versus permanent table. The default time travel retention period is 1 day, and if you set it to 0, then you would not be able to access any historical data for temp and transient tables. Now let's quickly see how the failsafe period looks like. The failsafe period for temp or transient table is always 0. It does not even change no matter whether you have a standard or a higher edition of Snowflake. Unlike permanent table where failsafe period is 7 days, for temporary and the transient table, it is always 0, and this is done for a purpose. If you are doing a lot of development activities and you don't want to retain the data because it is constantly changing, you can create a transient table instead of creating a permanent table. Because if you create a permanent table, even if you drop the table, you still have to incur the 7 days storage cost. So this is very important fact, and try to remember for your Snowflake Snow Pro certification. If you are not very sure, please refer the Snowflake Snow Pro certification playlist link above. So let's jump into Snowflake Web UI and have some hands-on exercise with time travel feature. Let me switch my context first. I'm going to create a table called tt_3_days. So I am keeping the data retention time in days equals to 3, and let me create this table. The table is created successfully. When I describe the describe table statement does not bring the data retention period. Here you can see I have total 9 fields and all the details are available starting from name to the data type and all other stuff. However, it does not show any data retention period. If I have to see the data retention period, then I have to use show table statement. So the retention field appears with show table. Alternatively, you can also see it via information schema, and let me run this query for you. And here the retention time is equals to 3. These are the two methods through which we can fetch the data retention period for a table. Now let's quickly load some sample data. Let me see how much data it has. Let's see how the data looks like. So this is the order table. Before I make some changes, let me understand how the min and max order looks like in this table. So this is how my min and max looks like. I'm going to execute this where clause and will perform an update operation. Before I perform an update operation, I would like to understand how many rows this where clause brings. So it brings 46 rows. Let me execute and update this dataset. Update order priority as urgent wherever it is not urgent. So 46 rows updated, and I'm going to record this query ID. So this is my query ID ending with 52. Now I'm going to drop few records from this table. It deleted 54 records, so I'm making a note here. So we started with a million row and then we updated almost 46 rows, and now we deleted 54 rows. Now let me see what is the row count. So this is what the row count looks like. So I can copy this statement and I can see what was. So now I would like to understand the table count before I executed this delete operation, and it should bring exactly a million record. So here I got a million rows. It means that this time travel is functioning appropriately. This is how I can use before keyword with extended SQL. I can also change it to at. And this brings 999946 record. So again, perfectly fine. We can join and find all the records which are dropped between these two statements. However, I would not prefer to run this join operation because this will be pretty expensive join operation. So I would prefer a minus operation. So here what I'm doing it, I'm trying to fetch all the record before I executed this statement, which represent the delete statement followed by the current state of the table. And here I got exactly 54 rows which got deleted. There is another way that you can execute using a not exist query approach. This also brings exactly the 54 rows which we deleted before this statement AB96. You can also use offset keywords. So following query selects historical data from the table. So I will change this to make it count. So let me run this count operation on this table. I'm using the keyword at and offset, and I'm trying to fetch how the table looked like 300 seconds ago. 300 seconds ago, my total count was a million. If I say 60 seconds ago, so 60 seconds ago, 9,946. Alternatively, I can also use timestamp based approach to fetch the dataset. You can also execute the alter statement and change the data retention period from 3 days to 5 days. And in that case, what would happen? My retention duration will extend to 5 days and there would not be any data loss. So let me execute this alter statement. And let's validate the retention period. Now I can see my retention period has been changed to 5. Now if I change the retention periods from 3 to 2 days, and here you can see my retention duration has changed from 5 to 2. So this is how you can change the retention duration to any number less than or equal to 90. Decreasing the retention period will lead to data loss. Any changes done during that period will not appear through the extended SQL. Now let's understand how the transient and temporary table works. So I'm going to create a transient table with name TT0 days transient table. It is exactly the same structure and I am keeping the retention period equals to 0. So this got executed. I'm going to have another transient table where I'm specifying the retention period equals to 1. And this will also work properly. So I got my another table created successfully. Now when I'm trying to set the retention period for a transient table equals to 2 days, it doesn't work, and let me show you. And I ended up with SQL error because value 2 is not supported for transient table or a temporary table. Same is applicable for the temporary table, and let me run this for you. And surprisingly, this statement executed successfully. I'm going to validate the retention period, but strangely Snowflake does not throw any error. So should we assume that it has considered this value or not? Let's check the show table command. Here my retention period for tt_2_days_tmp is equals to 1, even though we have specified on the line number 194 the data retention time in days equals to 2. I don't know whether it is a bug or this is how the Snowflake is designed. This is one of the important observation. Now the next question is that what if we define a permanent table with 100 days of retention period? Let's try that out. So this says exceed maximum allowable retention time 90. This is what I was expecting when I was trying to run for the temporary table or even for the transient table. This is how you can define the data retention time in days which is less than equal to 90 days, starting from 0 max to 90 days. And for a temporary or a transient table, it should be either 0 or 1 value. Any value higher than 1, it does not consider for temporary or a transient table. Now we will understand drop and undrop functionalities. So I'm going to create a table called time travel undrop with a retention period 3 days. So my table is created successfully. Now let me insert few records. I got 100 record inserted into this table. Let's drop this table. Now the table is dropped. Let's query it and Snowflake will say the object does not exist or not authorized. Now I can use undrop table followed by the name of the table which I have just dropped mistakenly or knowingly. However, this is not possible in any other traditional database. My table got undropped successfully. However, if I change my data retention period equals to 0, in that case, I won't be able to execute this line number 37 and it will start complaining that the object does not have any time retention period. I cannot recover the data. I had 100 rows in this table and now if I perform select star from this table, I would be able to see all the data. So this is how undrop works with respect to a table. Now let's try to see if I can also undrop a schema as well as a database. Before that, I switch my role to the system admin. I am creating a database called tt_db_undrop. I am creating a schema under this database and I am creating a table called tt_undrop and inserting a handful of values. So I have not used any time travel period, and if I do not specify, Snowflakes automatically assign a time travel period equals to 1 day. Now let's see how the database looks like. So I can see I have one database called tt_db_undrop. Now by default, it has a retention period of 1 day even though I have not specified. Same, let me check for the schema. So my schema tt_schema_undrop is created under the database tt_db_undrop and it has a retention value equals to 1. Let's list the table. So I can see under this undrop database, under this undrop schema, I have a table undrop and it has a total 5 rows occupying 124 bytes and having a retention duration equals to 1. So now I'm selecting this dataset. So I selected this table and I got all the result. And now I'm going to drop this database itself. So my database got dropped successfully and this statement will not bring any result. So I did not find any dataset. Now I can undrop this database and I can drop this schema. This also does not bring any table. Now I can undrop this schema and I can run the select statement. I got all the data back. So this is how the drop undrop functionality works. However, you have to make sure that your undrop function will work only if you have a retention period value more than 0. Otherwise, it will not be able to recover the database or schema as well as the table. Next, we will understand how the cloning works with respect to time travel. So I'm going to create a table called td_before_clone and this table is having a retention duration equals to 3 days. My table got created successfully. Now I'm going to insert 100 records. Now let's see how the table looks like. Now let's perform some delete, update and insert operation and record the query ID. So 23 records got deleted. So I copied the query ID. So this table has only 77 records left. Let's see how many records does it have. It has 77 rows. Now let's perform some update operation. The 20 rows got updated. Let's see how much dataset does it have. It should have exactly the 77 rows. So I have 77 rows. Now let's insert 50 record to this before clone table. Let's check how many total record does it have. So I have total 127 rows available. Perfectly fine. Now I'm going to create a table called tt after clone using a clone keyword. I'm going to consider this statement ID. It means that my clone table will have only 77 rows. So I'm going to create a table using a clone operation, and the clone operation will consider the state of the table before this statement. Let me run this query for you. So my tt underscore after underscore clone table has been created successfully. Let's see how does it look like. So I have a before clone and after clone, and both of them are having a retention duration equals to 3 days because the table is created using the clone keyword. And the after clone is having only 77 rows because we have used this extended SQL statement to create the clone table. Let me execute the table count. So before clone it is having 127 record. After clone is having a 77 record. Now time travel data is not available for the cloned table. So if I execute the before clone table with the statement, I am taking this query ID because this is the statement on which we deleted 23 records, and I'm going to execute a select count on the before clone table. This statement gave me 100 records. I was under impression if I execute the same statement ID for the after clone table, I would be able to get the same set of result. No, because this particular statement was executed for this table and not applicable for this table. So the clone table does not have any history of the table through which it has been created. So please make sure that nothing is preserved when you create a clone table. It is a point in time snapshot, and from there it builds its own history. Now let's see how we can create a table without using a clone statement but using a select statement along with extended time travel SQL keywords. So here I am creating a table tt underscore as underscore select as select star from tt underscore before underscore clone using before statement. My table got created successfully. Let me see how many record does it have. So I have 100 rows. Now there is a difference between creating a table this way or creating a table through the clone keyword. When you create a table using this approach, you actually create a physical table. However, when you create a table using a clone, it is a zero copy clone that we are going to cover in detail in the next chapter. Now let's understand how to track how much data is being stored for a time travel feature. To do that, you have to first change your role to the account admin. We have to fire a query onto the table storage matrix, and this object belongs to your account usage under Snowflake database. And let me execute this query for my table schema CH14. And this is how the result looks like. Here you can see this active byte shows what is the current state of your table and how much data does it store. On the other side, you can see the time travel bytes. And if you have any time travel related data is there, that will be shown. And the third one is that failsafe byte, that how much data is available in the failsafes. So this table helps you to understand how much data is being stored in your active bytes, followed by time travel bytes, followed by the safe bytes. How to calculate the time travel cost versus table storage cost? And let's assume that we are paying roughly $40 per terabyte per month, and I can use this query to understand my total cost based on my storage. I can really see my storage cost with respect to active data, time travel data, and the fail-safe data. If I want to do this for all my schema, let me execute this query. And this shows that how much data set I have it on my active, time travel, and the fail-safe. Right now, I do not have time travel data available, and this schema takes few hours to reflect your time travel data. So once you have a lot of time travel data available, you would be able to understand how much additional storage you are occupying to enable your time travel feature, and accordingly, you can compute your total storage cost considering active, time travel, and fail-safe storage baskets. This is not a perfect calculation, this is just a representative calculation, and if you understand how much you are paying per terabyte per month, you can perform a calculation as per your requirement. Now let's go into the SnowSight and try to understand, does it show any time travel data retention information for the table. I go under the database tab, click on my database and click on chapter 14 and go inside the table. And here, and if I click on this table tt_before_clone, I see it does not show any data retention related information. Right now, SnowSight does not show data retention parameter, and you have to really use show table statement. If you have to really understand the storage cost, SnowSight has a view under the account, and for which you have to switch the role to the account admin. And I go to the account tab, I click on the usage. And if I click on the storage, it breaks down your data into 3 categories called database, which is active, followed by failsafe, and followed by your stages. It still does not show the time travel. Since SnowSight is still in a preview version, maybe in future it will enhance this screen and will also show you what is the storage occupied by the time travel feature at database level. I hope this summary and the live walkthrough of the time travel feature has been a meaningful session for you. We managed to see some of the use cases which can be applied using time travel features, and there are many more. And if you are still enjoying this Snowflake guided tour, you must be excited to know what is this cloning feature and what does it mean by zero copy clone. Can I just copy tables or a databases or a schema or any other object within Snowflake? To understand everything in detail, you have to jump to the next chapter, chapter 15.